Let P of t be the population in millions of a certain county t years after 1800, and that P of t satisfies the differential equation P prime of t equals 0.02 P of t, and P of 0 equals 3. Okay, so the first thing is this 0.02t, that tells me that's my k right here. That's my k value. And my initial population is 3. So P of t is actually pretty easy. P of t equals 3 e to the 0.02t. So the one thing that kind of worries me is that means there was, oh, it's in millions. Okay, that makes more sense. I was going to say there's a county that started with 3 people, but it's actually 3 million people. Okay, that makes more sense. So the initial size of the population was 3 million. Part B. What was the population in 1800? So this is kind of a weird thing. I'm letting t be years after 1800. So if I put t equals 0 in, I already did that. T equals 0 equals 3. So it's just 3 million. So what was the population in 1810? So I'm doing years after 1800. So this is t equals 10. So P of 10 equals 3 e to the 0.02 times 10. Okay, 3e to the 0.02 times 10 is 3.664, and we aren't going to forget this is in millions. And actually, I should be more clear than that. It's million people. It's quite a few people. So it does seem to be growing pretty darn slowly. When did the population reach 20 million? So 20 equals 3 e to the 0.02 t divided by 3. Natural log of both sides. So natural log and e will cancel, and we'll just get the exponent left. So then t is going to equal the natural log of 20 divided by 3 all over 0.02. So putting that into a calculator, okay, so this actually fits well. I get 94.86 years. So at first I was a little worried when I got this answer, because that means it's growing pretty slowly. If it went from 3 million people to 3.664 million people in 10 years. But this is saying for it to get all the way up to 20, that's like nearly 100 years later. So it is growing pretty slowly. That does seem to make sense.